Hi, welcome to Donegal Dad. I'm Mark. Hello to all my new subscribers, and if you are new here, hit that subscribe button. Today we're going to be looking at hardwiring a decoder into this Class 37. This is a model of a Class 37 by Hornby. It's over 30 years old. It's got a 3-pole ring-field motor in it, and today I'm going to show you how to hardwire a decoder into it. So the first thing we need to do is test it. Now this hasn't been run for probably 20 years. So I've put it on the test track here. I've hooked up my Gauge Master power supply, because if it doesn't run well on DC, it's not going to run well on DCC. So it's on there. Let's turn on the power and see what happens. Oh, there's a bit of life, bit of movement. Yeah, it's very noisy. So the first thing we're going to do is we're going to give this a good service and get it running well on DC. So here you can see I've popped off the body shell, so it exposes the internal workings. Now how these work is we have the rail, which is connected to the controller by wires. So the current goes through one rail, up through the wheels, through a wire, into the motor, and then it returns through the other set of wheels, back through the track to the controller. So that's basically the workings of a model engine. Here we have the motor. It has 2 feeds into it. We have a little capacitor there, which we'll have to remove when we're doing the DCC conversion. And we can just pop this out. And then we have the motor. So in here we have the brushes, which connect onto the commutator, which makes the motor spin. And then on the other side we have the gearing that connects to the wheels and makes the wheels turn. How do electric motors work? Let's go over a little bit of the theory. So here we have a motor from another engine. This is an open one, so you can see the internal workings. So the power comes in through one of the brushes onto the commutator, which turns this section into an electromagnet. Here we have a fixed permanent magnet. So when this becomes electrified and magnetized, it opposes the poles on this magnet, which makes it spin away. And then it turns to a new section, which then becomes electrified and magnetized, again repelling from the magnet and spinning. And that process is repeated, and that's how a DC electric motor works. So to make these work better, we need to clean the wheels, so the contacts with the wheels and the rails. Make sure the brushes are the correct length and working, the commutator is clean, and the magnet is in good working condition. So we'll do some of that cleaning now on this, and we'll also need to give it a little bit of oil just to make sure it's well lubricated. So let's get started on that. You can see here on these wheels they're quite dirty and tarnished, so I'm going to use a 99% solution of IPA on a cotton earbud and just clean the wheel surfaces. So it gives a good contact on the rails and you get good electrical continuity. Now you want to make sure you're using 99% proof IPA, because the other 70% are made up of 30% water, and you don't want water left on the wheels because they can cause further corrosion. So I'll carry on doing this. You can see the IPA has removed a good bit of dirt, but there's still some in-ground dirt on there that just isn't coming off. One of the things you can use is a track rubber and just rub that on the wheels and slowly turn them to help remove the dirt. And now you can see you're in a bit of a shine back and you're getting back to the bare metal, so you should have a good contact. If you have some really stubborn dirt and corrosion that will not move with IPA or the track rubber, you have the option of using your Dremel type tool. Use a brass brush attachment. This is a lot softer than steel and won't leave as many scratches and scores on your wheels, because if you scratch the wheels, you can end up with more problems where it will accumulate dirt much quicker. So to do this, make sure you're wearing safety goggles. Put it on, have it at a lowish speed, and just gently buff over the wheel surfaces. Just to get them clean. As I say, using the Dremel type tool should be a last resort. Now you can see that's cleaned off a lot of the dirt and mess off of there. I'll give it a final clean now with IPA. So there's the wheels cleaned on the motor section. Let's put it on the rolling road and connect it to the power and see if there's any improvement. This is a DCC Concepts rolling road. Let's apply the power. There we go, it comes to life. And you can see now it's running a lot better than it was before, just simply by giving the wheels a good clean. But it's still a bit noisy, so I think we'll give it a little bit of an oil and see how it runs after that. So we need to oil the moving parts. So here I've got some oil I picked up in a model shop. This is very thin oil, it's like sewing machine oil for use on models. And you only need the slightest drop of oil. If you can see oil, then you've got too much on there. So I'll put some on, let it run, and then I'll clean off any excess oil. So you don't want too much oil on there, because if it gets down onto the wheels, it's going to destroy the contact and also give you traction problems. So let's put that back on the rolling road, let it run for a little while and see if the noise improves. Right, it's been running for a few minutes now, letting that oil work in, and as you can hear now, it's a lot quieter. So let's switch that off and take it off. And then I'll just get a dry cotton wool bud and just soak up any excess oil that's around. There we go. So the other pickup, I've done the same thing with the wheels on there. I've cleaned them. So let's put it back together, see how it runs. As you can see, the bogies are back in the chassis and it's running around quite happily. I've had it running now about 15 minutes in each direction. So we'll take it off now and we'll just have a look at a few other servicing things you can do before we do the conversion to DCC. Some of the other things you can do while you have your engine stripped down is check the back-to-back distance on the wheels. If you have a locomotive or even a wagon or a carriage that is skipping off points, it can sometimes be down to the back-to-back measurement. So you get yourself a little brass tool like this and you slot it between the wheels to make sure the gap is correct. Now with engines, they're going to have cogs on them, so you can't push them in all the way, otherwise it will then be too far apart and cause you even more problems. If after cleaning the wheels your engine is still not working properly, there's a couple of other things you can check. Check the continuity between the wheels into the chassis and into the wire, so using something like a multimeter to check that. It may also be that the brushes inside here need replacing, they could be worn down. And you may have to strip the motor down further so you can get access to the commutator and give that a clean. Again, using some IPA just to clean it off and get rid of all the carbon deposits that build up on it from the brushes. And all these little things should help your locomotives run a lot better. So this is the decoder we're going to fit. Now this has got a plug on it, 8-pin plug. Obviously we're not going to use that because we're hardwiring this in. So first thing we need to do is cut that off. There it goes. Now this is an 8-pin decoder, so it's got 4 functions on it, which can be used for lights, cab lighting, that sort of thing. So we're just going to use this decoder just to move the locomotive, so we're only worried about the grey and orange wire. Which go to the engine. So they go onto the motor. And then we have the black and red, which will go onto the pickups. So the other wires we don't need to worry about. Now we could cut them off, but I tend to like to leave them in case at a later date I want to come back and fit lights or something else to this engine. So I just tie them off like that. On the back of the decoder you have another 2 wires. These are for fitting a stay alive, which something like this, which only has 2 pickups, one on this bogie and one on this bogie, can help you when you're going over point work, so the engine keeps going and doesn't cut out. So maybe at a later date we'll fit a stay alive to this. So those are the wires we're concerned about. So grey and orange to the motor and black and red to the pickups. Now when you solder these on, if you solder onto the motor and then you hook it up and you realise your engine is going the wrong direction to the DCC, you can either desolder them and just swap them around, or look at the manual for your decoder and there should be one of the CVs in there to reverse the direction. So let's get this ready to solder on. So I've taken the capacitor off, we don't need that anymore, put that to one side. I've disconnected the power from this terminal. Now some of these older chassis wouldn't have this plastic part, it would all be metal, and this terminal here would be connected directly to the chassis, so you would need to put an insulating washer in so it isn't directly connected to the chassis, so you can wire the DCC chip in. This is an example of one here. I've had to put a different screw in so it doesn't go all the way through to the chassis to make the electrical connection for this terminal. So I've stripped the wires on the decoder, so now I'm just tinning the wires. And these are the wires that connect to the bogies to supply the power. So I've just cut the ends off them and stripped them, and I'm just tinning them. So I've cleaned off these terminals. Now I'm going to put a drop of solder onto each one. Just a little dab. Like so. So we want the grey and the orange to solder onto the motor. We'll just give them a little trim. So we'll put those on. I said before, if when you connect these up, it doesn't run in the right direction, you can just desolder. And reverse the connections. There's one on. Now the orange. we go. That's those on. Now we can do the supply that goes to the pickups. So I put a little bit of heat shrink over here first. Just give them a little trim. The solder out ready. A bit of solder. Hold it on together. There we are. There's the connection made. So I'll repeat that now with the other one. So there's the chip soldered in. So the orange and grey going to the motor, the black and red going onto the feeds. A little bit of heat shrink over them to stop anything shorting out if it touches on the inside. So we'll get the DCC controller out now and give it a test and see if it works. So it's on the track. I've taped down the chip to the top of the weight there and tidied up some of the wires to keep it a bit more secure. I've connected up my Railmaster to the track. So let's give it a go and see if it works. And away she goes. And we'll try her in reverse. There we go. We'll put the shell back on her now and let her have a good run around. So there we have another DCC converted loco added to my fleet. Hope you found that useful on how to hardwire a decoder into your engine. So please don't forget to like, subscribe and share. Leave your comments down below. And thanks for watching. I'll see you next time. Bye for now.